Fair enough. So volumes of prisms and cylinders, I actually got a little excited in section 6 and kind of wrote the equation there. But we talked about for rectangular prisms, volume was length times width times height. That's what they teach you in all the grades up until perhaps now. But I gave you this other equation, volume equals capital B times H. And when we had other equations, I wouldn't write this, but when you're talking about the area of a triangle, we had like a lowercase b. So area of a triangle is half of lowercase b times height. When we did that, this b here was the length of the base. So lowercase letters typically always are going to be lengths. Where now, when we have this capital B's, anyone remember what we said that was in the notes? Nice, it's the area of the base. And part of it begs the question, well, what's the base? I could see where for this first one, the whole thing isn't drawn in, but I have this object here, so I'll kind of put in this hidden line back here and another one. So I could see where it'd be tempting to say, oh, it's sitting on this bottom edge. That has to be the base. Can you kind of picture it with my drawing? But that can't be the base. If you have a prism, what has to be true about the bases of a prism? Does anyone remember? Perfect. They have to be parallel, and there was one other thing. So there has to be two of them. They're parallel and congruent, or you could say identical if you wanted to. The math word is congruent. So for this first object, my base has to be what shape?
Rectangle.
The triangle. Because we have one triangle here on this end, and then if you could see through it, you'd have an identical triangle back here. That those two are parallel, they're both vertical in the picture, and they're both exactly the same shape. Can you kind of picture that? So that's one thing you got to kind of train your brain a little bit to, okay, what's the base? Well, look for two of them. And when we have these prisms or cylinders, there's always going to be two bases. Okay, so the H then, is the H, I'll get back to the H. All right, so we need to find the area of the base. So I want to say volume, for example, 1, capital B times H. So we need to find the area of that triangle, agreed? 1/2 lowercase b times H. So area of a triangle is 1/2 lowercase b times H. Lowercase b is going to be 6. You could put in 6 inches if you wanted to. Height is going to be 5 1/4 or 5.25. So we get 3 times that, so 15.75. And that'd be square inches if we were going through and like actually doing all the unit stuff. Maybe I'll write it in, inches squared. But now the base then is going to be 15.75, the area of the base. We okay for that?
Mm-hmm.
My height, is my height this 5 1/4 again?
Yes.
No.
Should be the, exactly, the 38 1/4. And the height is going to be this, and I'm going to add to my little equation up above. That has to be the distance between the bases. Here's kind of how I look at it. This is kind of skewing maybe your vision of area a little bit, but when we found the area here, when we found the area of this edge, we kind of found out it's really just two-dimensional. It's flat. It doesn't have any height to it. But when we start talking about base, when we start talking about volume, you go look at it as though, well, we have that area, this 38 1/4 times. So it's kind of like saying, if I take a 1-inch wedge of that, so say now this is 1 inch of my 38 1/4 inches, that area there is going to be that one wedge. Well, when I multiply by 38 1/4, what I'm really doing is saying I have that many area, or I have that much area 38 1/4 times. So I'm kind of multiplying by the number of those triangle-shaped wedges it takes to fill the whole thing. Can you kind of picture that a little bit? For me, that's how my brain makes this section make sense. So 38.25 or 38 1/4. But anyways, you take the area of the base, multiply by how many layers you would have to connect those two bases, and then we get our final answer of 602.4375. And if we just found volume, and all of our measurements are in inches, units here would be inches cubed. Yep, because volume will always be to the 3rd power. So essentially we did a base times width times height kind of thing. So, is that okay for example 1? That's really the whole section. Example 2, I just wanted to show you that it's not always going to be, a triangle. Sometimes you have for this, if we're trying to find the area of the base, V equals capital B times H. Now the base is a, Nate, perfect. So you could look at it as though it's this bottom one if you wanted to. I picture it that way more than the top. But if we want to get that, we say, okay, so area is pi r squared, right? Need the circle equation for area, for a base of circle. And we want the radius, which is from the inside, the center, to the outside. Length of 9. So pi times 9 squared. You could do a decimal. But if I were to do a decimal, the 9, do you agree we're getting the 9 from half of that 18? Right there. So the diameter is 18, you cut it in half, you get the radius. So if you want the exact answer, I would just leave this 81 pi. 81 pi in for capital B. And if you were to do the decimal is going to be 254. I'm going to write that down lower, but I would encourage it, if unless your brain like totally seizes up with having the 81 pi, I'd leave it in there instead of doing the decimal, because I just rounded this here. Now my height is going to be this 9, right? Kind of how many of these layers I'd have to fill the whole thing. Well, if I go with this rounded one down here, when I multiply by 9, I just made my rounding 9 times bigger. Where if you leave it at an 81 pi, your calculator hasn't rounded yet. You'll get a more exact answer. And so I would get, gotta find it here. So 2,290. So 2,290.22. And that would be inches cubed. Inches cubed. The other way to do it is to actually write your work like this here. But you know how if you just do like a times 9, your calculator will fill in the ANS for you? So even though maybe you wrote this here, if you do times 9, then your calculator takes the number with all those decimals and multiplies it by 9. So, but anywho, that's it for section 8. You guys, questions? Feel excited? Excited for this?